left aside, what do? You count this one as a single letter, not as separate letters anymore. You count them as what? A single letter. So when you want to count, this will be 1, 2, 3, 4. So in the remaining arrangement, what is left to be arranged? 4 letters. I'm going to take that again. You want to arrange boy, girl, but there is a condition that is attached to it. The condition is that BGI must be together. The condition is BGI must be together. So the first thing you are going to do is you rearrange the letters. And when we rearrange the letters, BGI of course are together, right? And then we left the remaining letters aside. Remember that the remaining letters, they are still part of the letters we are. You will see that we have rearranged this already. We have BGI and then we have OYRL. So now if you want to evaluate this, what do? You first of all take BGI into consideration, which we have done. So when you take BGI into consideration, how many letters do you have? 3 factorial. You do that and you keep it aside. Now, when you keep BGI aside, it means that in every arrangement that you want to do, you will be seeing BGI as what? As one letters, because they must be together. You are not separating them again. Anyhow you want to arrange this, BGI must be what? Must be together. So if you want to put other letters into consideration, when you want to count, after this 3 factorial, what do? You say times. How many letters do you have? 1. BGI. The whole of BGI will be 1 letter. Then OY, how do you? This one will be second letter 2. This one will be third letter 3. This one will be fourth letter 4. And this one will be what? The 5th letter, which is what? 5. So when you want to evaluate this now, you say that the arrangement will be what? Will be equals to 3 factorial times 5 factorial. I hope that is clear. Again, boy, girl. You want to arrange boy, girl. Unlike the first question, you are just asked to arrange normally. In how many ways can you arrange last term? There is no condition that is attached. So the last thing that you have 7 letters, and you want to arrange 7 letters. So that is why you have 7 permutation 7. You have 7 letters and you are still arranging 7 letters. But in the case of boy, girl, there is a condition. How many letters is here? 1, 2, 3, 4, 5, 6, 7. Now, the 7 letters in boy, girl that you want to arrange now, there is a condition that says that BGI must be together. So if BGI must be together, it means that when you are rearranging, the only one that will be giving you problem is OYRL, right? Because you already know that BGI, they are not going anywhere. They will always be together. So at some point, you take them as what? As 1 letters. But before you take them as 1 letters, you need to put them in consideration. That how many letters must be together, which is 3 letters, BGI. This is this 3 factorial. You write 3 factorial. Times how many letters that is left. When you are considering the number of letters that is left to be arranged, then you now count BGI as 1 letter. And then you count the others. BGI 1, O 2, Y 3, R 4, L 5. So 3 factorial times 5 factorial, what will it give us? 3 factorial times 5 factorial. This is 6 times 120. That's going to give us 720 ways. I want to believe this is very clear. So now let's quickly move to example 3. Now the third question. In how many ways can the word boy girl be arranged such that BGI must not be together? So what is going to happen? If it had been, in how many ways can the word boy girl be arranged? You know, I already said it's going to be 7 permutation 7, right? So when you are doing 7 permutation 7, that means you are taking into consideration all letters irrespective of the arrangements, right? Now there is a condition. The condition is that BGI must not be together. Remember in example 2, we say BGI must be together. So which means that if I want to get the total arrangement that I can have, the total arrangement I can have will be equals to the number of ways at which boy girl can be arranged such that BGI must be together plus the number of what? The number of ways at which BGI must not be together. What I'm saying in essence is, you know, the total arrangement for boy girl will be what? What's the total arrangement for boy girl? Total arrangement for boy girl will be what? Let me write it in capital letter. Total arrangement for boy girl will be equals to 7 factorial. Total arrangement for boy girl is what? 7 factorial. And that gives us 5040 ways. Now, in the previous example, we have explained that if you want to, what number of ways are we going to have if you are going to arrange boy girl such that BGI must be together? What did you get? At that point, we have that number of ways if BGI must be together is what? We have 3 factorial times 5 factorial, which gives us what? 720 ways. Now, what they ask us to find is number of ways at which, okay, let me say number of ways if BGI must not be together. If BGI must not be together, let's say it is X. So, total arrangement will now be total arrangement of boy girl is equals to number of ways if BGI are together plus number of ways if BGI are not together. So now, out of these 3 unknowns, we already know 2, Abby. Out of these 3 parameters, we have 2 knowns. We know the total arrangement of boy girl, and we also know the total arrangement of boy girl if BGI are together. So what do? Just substitute your values. This will be equals 5040 ways is equals to 720 ways plus X. So your X will be what? 5040 ways minus 720 ways. And that will give us what? 4320 ways. I want to believe this is also clear.